मु जहाँ नोटिस कली 2022-23 रे बहुत सारा प्रोबेबिलिटी और कंडीशनल प्रोबेबिलिटी सब क्वेश्चन आस्थिला।
अच्छा तो आम देखिए सेटा माने कंडीशनल प्रोबेबिलिटी सेटा तो देखिले हमको जना पड़ियो ना 23 कारण मते लागु जे इथर रिपीट हबो। ओके
आज्ञा
ओके मु जोटा तुमको देखा पे चाहूले 1 सेकंड लेट मी राइट इट I hope the screen is visible, right? Is the screen visible?
Yes, sir,
yes
visible.
sir
Okay. काली मु गोटे आपन कही गोटे सिंपल हमर जो सिग्मा स्क्वायर एक्स थिला सिग्मा स्क्वायर मु जानी नहीं को माने से फार्मूला डिराइव करले आम केमिति सिग्मा स्क्वायर एक्स इन टर्म्स ऑफ एक्सपेक्टेड वैल्यू केमिति लिखिबा नहीं कि एटा थिला तो एटा बेसिकली x माइनस म्यू एक्स रो होल स्क्वायर राइट तो एटा को ओपन करि परिबे ब्रैकेट एक्सपेक्टेड वैल्यू ऑफ मधुसूदन एटा करि परिबो x स्क्वायर माइनस
हाँ सर
Mu
a
x
plus b
square
whole
2
square
mu x.
a minus
हाँ a माइनस बी होल स्क्वायर प्लस म्यू स्क्वायर एक्स जदि ओपन करना देखिबो लास्ट को तुमको जीव तुम एमती तापरे करिवो कहीं मुझे कहूँ तुमको एमती एप्लिकेशन इकोनोमेट्रिक्स रे बहुत फास्ट करिवार अछि प्लस एक्सपेक्टेड वैल्यू ऑफ माइनस 2 म्यू एक्स इंटू एक्स प्लस एक्सपेक्टेड वैल्यू ऑफ म्यू स्क्वायर एक्स है so is equal to expected value of x square minus 2 mu x into expected value of x plus mu square x. Is it clear?
yes sir
ना किसी प्रॉब्लम अच्छे माइनस 2 म्यू स्क्वायर एक्स कारण एक्सपेक्टेड वैल्यू ऑफ एक्स म्यू एक्स हम राइट प्लस म्यू स्क्वायर एक्स तापर एटा हैला एक्सपेक्टेड वैल्यू ऑफ एक्स स्क्वायर माइनस म्यू स्क्वायर एक्स टा जोटा एक्सपेक्टेड वैल्यू ऑफ एक्स बुझ पारल कि नहीं तो हमर एटा गोटे बहुत इम्पोर्टेंट कारण मत लगुच गोटे क्वेश्चन एथर आसी एग्जाम रे बोधे मो क्वांटिटी मेथड्स 1 ले आसला बोधे इफ y इज इक्वल टू 2x plus 3 calculate expected value of y मते काली देखै परिबो माने कॉलेज रे and just write it down okay so that this is equal to 2 times expected value of x plus 3 okay can you try means not right now after the class
प्रूव करिबु ना कोन सा एटा
हाँ डेफिनेटली कारण आम ये एक्स टा कौन एक्स टा मुझे कहूँ जे क्वेश्चन फुल क्वेश्चन हूँ लेट एक्स बी द टू X is the total when the two dice are thrown. So calculate the possible values of Y. So directly also you can do it, not a problem. X is another random variable when two dice are thrown. Okay. तब एटा को प्रूव करार नाइ एटा को कैलकुलेट करार अछि एटा देखार अछि जे एक्सपेक्टेड वैल्यू जोटा हमर y is equal to, if y is equal to 2x plus 3, then what is the expected value of y? Okay, this is one question. And similarly we have other questions also. Suppose variance rule, whether yesterday we have covered the variance rule, covariance rule and variance rule.
No, sir.
Yes or no?
No, sir.
Okay. Random variable. Okay. So let me write covariance rule, because these are very important formulas. They are very crucial. So first, rule 1. Please write it down. Okay. Rule 1 is, if y is equal to v plus w, then covariance of x y is equal to covariance of x b plus covariance of x.
Hello,
Okay.
sir. Board is not working.
Huh?
Whatever you have written in the board, it is not visible, sir. If
Uh-huh.
y equal to is signed, after that it is not working.
Okay, it is not visible, right?
Now it is visible, sir.
Okay, now it is visible. Okay, thank you. So if y is equal to v plus w, then covariance of xy will be equal to covariance of xv plus covariance of xw. Okay, this is first property. So how you will prove this? If I will ask you to prove this, Bhakti ma'am.
Sir, I have put the formula covariance between x, y, and in place of y, we have to write b plus w. And let covariance of x and y equal to expected value of x minus x bar into y minus y bar. In place of y, we have to write b plus w. And in place of y bar, we have to write b bar plus
Yes.
w bar.
Yes.
We have to do the
Yes.
calculation now.
Yes. Yes. Thank you, ma'am. So let us do it. So if y is equal to v plus w and mu y is equal to mu v plus mu w. Okay. So already expected value rule number 1 is, what formula related to expected value you have learned? If you have remember, expected value rule number 1. Rule 1. Okay. Expected value of x plus y plus z. That is expected value of x plus expected value of y plus expected value of z. Okay. So this is the formula 1. Okay, which you have learned. So simply what you have to do, as Bhakti ma'am already gave some idea. So you just put the covariance formula, that is expected value x minus mu x. This is capital X Madhusudhan, are you able to follow?
ସାର୍ ମତେ କିଛି ବୁଝା ପଡୁନି।
କେମିତି କୋଉଟା ବୁଝା ପଡୁନି ମାନେ କୋଉ ଜାଗାରେ ବୁଝା ପଡୁନି?
ସାର୍ ଫାଷ୍ଟ ସେ ଯୋଉ ଏକ୍ସପେକ୍ଟେଡ ଭ୍ୟାଲୁଟା ଆ ସାଙ୍ଗରେ କେମିତି ଲିଙ୍କ ଅଛି ମୁଁ ବୁଝିପାରୁନି।
ସେଟା ଆମେ କରିବା ନା କରିବା
ଆଜ୍ଞା ଆଜ୍ଞା
ବଟ୍ ଫାଷ୍ଟ ଅଫ୍ ଅଲ୍ ଏଠି କୋଭେରିଆନ୍ସ ରୁଲ୍ କ'ଣ କହୁଛି? ଇଫ୍ y is equal to v plus w, covariance of xy, you have to prove that covariance of xy is equal to covariance of xv plus covariance of xw. Yes or no?
ୟେସ୍ ସାର୍ ୟେସ୍।
ଏଇଟାକୁ ଆମକୁ ପ୍ରୁଭ୍ କରିବାର ଅଛି, ରାଇଟ୍?
ଆଜ୍ଞା
ଏମିତି ଲିଙ୍କ ହେଲା ଏଠି ଦେଖୁନ, ଲିଙ୍କ ଡେଫିନେଟଲି ଏଠି ଅଛି, କାହିଁକି ଏଟା v plus w ଅଛି ନା, ଏଟା ଏକ୍ସପେକ୍ଟେଡ ଭ୍ୟାଲୁ ଅଫ x plus y plus z ଅଛି, ତ ଡେଫିନେଟଲି ଏଠି ଲିଙ୍କ ଅଛି। ଦେଖ ତମେ ଆଗକୁ ଯାଇକି, ରାଇଟ୍? ତ ଆମେ y ଜାଗାରେ କ'ଣ ପୁଟ୍ କରିବା? କହିବେ ତମେ?
ଏକ୍ସପେକ୍ଟେଡ ୱାଇ
ନା 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 ନା, y is equal to
V
what?
plus W, sir.
ହଁ, v plus w
ହଁ
କରିବା।
ହଁ ସାର୍ ଠିକ କଥା କହିଲେ। ହଁ ଭି ପ୍ଲସ୍ ଡବ୍ଲ୍ୟୁ।
Yes. So we will put v plus w. Okay. Bhakti ma'am, correct me if I am wrong. Okay.
Okay, sir.
Then mu v plus mu w. Okay. So expected value. Now you can see it is expected value of x minus mu x into v minus mu v. Okay. Min- v minus mu v plus x minus mu x into w minus mu w clear? So it is covariance of xv plus covariance of xw. Bhakti ma'am, is it clear?
Yes, sir.
Madhusudhan, are you able to understand now?
Sir, why we subtract mu v and plus mu w?
Where?
Expected value.
See here what it is.
Yes, sir.
Mu, first of all, you just see what we had written. Expected value. This is x. Expected value of x minus mu x. Correct?
Yes, sir. Yes.
Into what we had written? In place of
Y.
y, we had written. I think I forgot to write the first part, maybe, or I have written somewhere. That is the reason maybe you are getting confused. Well, one second, let me write the first part. So basically, covariance of xy formula is, okay, what is the covariance formula? Expected value of x minus mu x, okay,
Yes, sir.
into y minus mu y, okay.
Yes, sir. Yes.
This is the covariance formula. So now in place of y we have put actually v plus w, correct? This one.
Yes, sir.
And already we know that mu y is equal to mu v plus mu w, okay, clear?
Yes, sir.
So minus, you can see y minus mu y. So how much it is? It is mu v plus mu w. Yes or no?
Yes, sir. Yes, sir.
So now next, just you have to rearrange. or is there any problem?
No, sir. Now I understand, sir.
Okay, very good. Excellent. Bhakti ma'am, is it clear?
Yes, sir, clear.
Because in econometrics, I think we are going to use this kind of derivation frequently, right?
Yes, sir.
Although it is not that difficult, I think, but I hope Ajay, you have understood, right?
Yes, sir.
Ajay,
Yes, sir.
have you understood or you have not understood?
I have also some problem, but I will
So
solve it
what?
later. Okay. Don't worry.
Covariance rule number 2. What is covariance rule number 2? Covariance rule number 2 is if y is equal to bz, okay, bz, b is a constant, and z is a variable. Then covariance of xy is equal to b times covariance of xz. Bhakti ma'am,
Sir?
this one we can easily prove, right?
Yes, sir, yes.
Madhusmita,
Yes, sir.
you can prove or which is true? Yes or no?
Sir, actually, I am unable to prove. I need a more practice.
Now y is equal to bz. Okay. See, Bhakti ma'am, she is also trying. Na, whether she has remember everything, but she is trying.
Yes, sir.
So you should be inspired. So
Yes, sir.
mu y is equal to b times mu
Music.
z. Correct? I can write, right?
Yes, sir.
Then what is the problem? Now you can easily prove because covariance of xy formula already you know. I think Madhusada, you have to just say yes, I can do it.
Yes, sir.
Then
Actually, first of all, I have to remember it.
see, first of all, let me tell you.
Yes.
Although I have taught this subject for many years, all it is there in my mind only. So, but still, I'm just trying to help you out. So x minus mu x into I minus mu y. So now you just replace expected value of x minus mu x into y. In place of y, you put
BZ.
bz minus b mu z. So now what it will be? Because expected value one formula, if you have remember, that is why it is very important to remember all the formulas of expectation. Because these are you have to remember everything. So expected value of b times x will be, tell me, Madhusinda.
Sir, expected value of b time x is xb, I think.
No. It is a because this is a constant, na?
Constant. Yes, sir. X.
Expected
B
value of
into expected B into mu x k.
no. First of all, expected value of a constant is what? Constant, na?
Constant is constant, sir.
Then what it will be? So it will be b times expected value of x.
Yes, sir.
Then you have forgotten, I think. Yeah?
Yes.
Like, can you just tell me? Okay, let us see. If linear property, if y is equal to, because this is a linear function, right? b1 plus beta 2 x. Then find out expected value of y. So what it will be? It will be expected value of b1 plus b2 expected value of x. Hmm. Okay. So directly you can write b1 plus b2 times expected value of x. Not a problem. Correct? Now we'll go to this formula. So you can write b times expected value z minus mu z. So it is b times covariance of xz. Clear? Or is there any problem? Bhakti ma'am?
Clear, sir.
Okay. Ajay,
Yes, sir.
is it clear?
Yes, sir. Yes. Just we have to understand the basic mathematics. Then we can just addition, subtraction. Yes, sir.
Oh, basic mathematics, but if I will, Bhakti ma'am, one question. Okay.
Yes, sir.
If y is equal to bz, what will be the variance of y?
Variance of y, b square variance of z.
Ah, yes. The variance of y will be. This is a variance formula actually. It
Yes.
will be covariance of yy. Covariance of yy will be equal to curve of bzy. So that will be equal to b times curve zy. So that is basically ultimately it will come. If we will go further, it will be b square variance of z. Right? So whether covariance is independent of change of origin and change of scale, Bhakti madam? Means variance.
It is
Variance.
it is
Sorry.
independent.
Variance is change of
Change of free from change in scale. It's a change in origin, but not change in scale.
Okay. Because we can clearly see that this is b square times variance of z, isn't it? It is, Bhakti madam?
Ida.
କାରଣ ଆମେ ଆରମ୍ଭ କରିଥିଲେ ନା y is equal to bz ନା
आगे आगे.
डेफिनेटली b square variance of z ହେଇଗଲା b ଟା ଗୋଟେ constant which is multiplied. Means if there will be a proof that variance is actually depends on the change of scale. It is not independent of change of scale, right?
Right.
Madhusinda, you can prove it, right?
Sir, I have a doubt. So what is the basic difference between variance and covariance?
Basic difference. What you are saying?
Means the distinction covariance and where we calculate the covariance and variance. Means or simultaneously we calculate the covariance and
See,
variance.
okay, I think Bhakti ma'am will also answer. But let me tell you, I can write variance of x as covariance of x and x. Isn't it, Bhakti ma'am?
Yes, sir.
Now you can answer.
Ma'am, it means covariance is double. Means
O means
square of the
together
variance.
two variable are varying. When I say two, a variable is varying with itself, it becomes variance. O means together, na? Together varying. There's x variable, there's a y variable. How the variance of x is varying, changing with the variance of y. Variance को जीवनी x y together केम तांको vary करचुंदी.
कौन है ला मधुसूदन
ଏଇଠି ଆପଣ x x ଦିଟା ନେଇଛନ୍ତି ତ ସେଇଠି ମୋର ଡାଉଟ ହଉଛି କି ମ୍ୟାମ୍ ଯାହା କହିଲେ କି x ଆଉ y ଦିଟା ଆମର ଡାଟା ସେଟ୍ ଅଛି ତା ଭିତରେ ଯାହା ଭେରିଏନ୍ସ ଅଛି ମାନେ ଡାଟା ମାନଙ୍କ ଭିତରେ ଡାଟା ସେଟ୍ ଭିତରେ ତ ସେଟାକୁ ଆମେ କୋଭେରିଏନ୍ସ ନବା ତ ଆପଣ ଏଇଠି ଡବଲ x x ନେଇଛନ୍ତି
ଏଠି ମାନେ x ଟା ନିଜ ସହିତ କେମିତି vary କରୁଛି ସେଟାକୁ ଆମେ variance କହି ଦଉଛନ୍ତି.
ଆଚ୍ଛା ଆଚ୍ଛା
କାରଣ ଯଦି x y ହିଁ ଥାନ୍ତା ତାହେଲେ ଆମେ କଣ ଲେଖିଥାନ୍ତେ ରୁହ ମୁଁ ତମକୁ ଆଉ ଗୋଟେ ଯାଉଛି ଲେଖୁଛି ରୁହ ଦେଖ ଆମର ଯୋଉଟା ବର୍ତ୍ତମାନ ଅଛି ନା ଏଇଟା କହିଲେ ବଟ୍ ତମେ ଦେଖ ଆମେ ବେସିକାଲି ଯଦି ଆମ ପାଖରେ ଦୁଇଟା ରାଣ୍ଡମ୍ ଭେରିଏବଲ୍ ଅଛି x and y right so population covariance ଆମେ କେମିତି ଲେଖନ୍ତି ଏମିତି ଲେଖନ୍ତି curve of xy is equal to sigma xy ଏମିତି ଲେଖନ୍ତି ହେଲା population
ଆଜ୍ଞା
covariance. So population covariance is nothing but it is basically the expected value of the product of their deviation from their population mean. Okay. So basically you can write this as expected value of x minus mu x into y minus mu y. Is it clear?
yes sir
So mu x and mu y are population mean. Okay.
yes
Basically it is a measure of association. Okay.
yes
But it is not useful as correlation. Okay.
yes sir
Is it clear?
yes sir yes
Okay. Now let me ask you one question. Yesterday, if you have remembered, what we have learned, if x and y are independent, let me ask one question. Are independent, then expected value of xy will be Vasudha?
so it's if the x and y are independent then expected x plus expected
No.
value of x plus
Expected value of x into expected value of y. ବୁଝିପାରିଲ
yes sir independent case yes sir
କାଲି ଆମେ ପଢିଥିଲେ ନା ଏକ୍ସପେକ୍ଟେସନ ପଢି ନଥିଲେ କିନ୍ତୁ ଆମେ ଇଣ୍ଡିପେଣ୍ଡେଣ୍ଟ
हाँ probability case रे पढ़ते हैं
हाँ।
जब independent हुए आगे
ତାହେଲେ ମଲ୍ଟିପ୍ଲିକେସନ ଆମେ ଯୋଉଟା କରୁଛନ୍ତି ସେଟା ଏଇ ଟାଇପ୍ସରେ ଲେଖିଲେ ଆମେ ବେସିକାଲି ତାପରେ ଆମେ ତାକୁ ଯଦି ଏକ୍ସପାନ୍ସନ କରିବା that if x and y are independent ତାହେଲେ population covariance will be equal to 0 ବୁଝିପାରିଲ
आगे
କାରଣ ଆମେ ଫର୍ମୁଲାରେ ଯଦି ପୁଟ୍ କରିବା ତାହେଲେ କ'ଣ ହେବ expected value of x so by virtue of the fact that expected value of x will be equal to mu x and expected value of y is equal to mu y. So obviously when you will open the bracket, so it will be 0 into 0. Clear?
yes sir
ताले हमें कौन जान ले covariance of two independent event will be equal to 0 means there is no association, right?
yes
So now covariance Rule 2 already we have proved. Covariance rule 3, although it is not that important rule, but you should remember. If y is equal to b, mu y is equal to b, then covariance of xy will be equal to expected value of, anyone want to guess what it will be? It will be x
X
minus
minus mu x into
y
y minus mu y.
mu y. But what will be the answer?
0.
0. It will be 0 only. Okay. See, these three rules are very important. Other rules are okay. If the y is a linear function, okay, linear function is very important. This one you can easily tell me. Let me write, if y is equal to b1 plus b2z, where b1 and b2 are constant and z is a variable, okay, random variable, then okay, Madhusudha, are you doing?
Yes, sir.
So basically this is a linear function, right? Like OLS equation, standard OLS equation. Are you getting?
Yes, sir.
So what it will be? Now it will be like this, curve of x comma b1 plus curve of x b2 z. Okay.
Yes, sir.
Then it will be b2 times curve of xz. Okay, is it clear?
Yes, sir.
Similarly, all these rules will be for covariance. Three rules we have learned. Similarly, you can learn the rule for the variance. Okay. So what are the rules? Basically straightforward. These rules are basically straightforward. Already you know it, so simply you can prove it, right? So first rule number 1. Rule number 1. So what is rule number 1? If y is equal to
V plus W.
b plus w, very good. So variance of y will be equal to variance of v plus variance of w plus 2 covariance of vw. This is first. Then rule 2. Rule 2 is if y is equal to bz, then variance of y will be b square variance of z. Then rule 3. Sangeeta, are you able to understand? I think she is not there. Where b is a constant, variance of y is equal to 0.
Sir, rule 3 is if y equal to bz, na?
Eh?
Rule 3 is if y equal to bz. You have written b only.
Rule 3. Rule 2 is y is equal to bz.
Yes, sir.
Rule 3 is B, y equal to B only.
Variance of a constant will be equal to 0 only. Okay?
Okay, sir, okay.
Thank you Ajay for clarifying the doubt. So if y is equal to b plus b, where b is a constant, so variance of y will be equal to variance of b. Okay? Where b is a constant. Now already we know that because it is a measure of association, right? Correlation. Yeah. The covariance basically a measure of association between x and y, but it is unsatisfactory, right? Now correlation. What is the correlation formula in terms of covariance? Let me go straight away. Ajay. We write like this. This is called.
Yes, sir.
This is rho xy. Rho is the correlation. Basically, it is population correlation coefficient, right? And it is dimensionless, and it is invariant to change in the unit of measure. Clear? So basically, rho you can write rho or r also. Clear?
Sir, it is invariant to change in.
Invariant to change in the units of measure. First of all, correlation coefficient is a better measure of association, and it is invariant, it is dimensionless, and it is invariant to change in the unit of measure. Okay?
Yes, sir.
So rho xy will be equal to sigma xy upon, who will tell, sigma square x into sigma square y. So now you see the numerator, what is happening? Numerator having unit of measurement of both x and y, right? And in the denominator Okay. So what it is having? It is having the squared unit of measurement of the all these variables. Yes or no? But once you take the square root, then the unit of measurement are the same as the of the numerator. So then it will get cancelled out. Is it clear? So that is why the correlation coefficient is unit free. Is it clear?
Sir,
Madhusudha?
can you again repeat? Sir, can you?
See, this is variance, na?
Sir.
What I'm telling you, if you take the this formula, so once you take the square root, then sigma xy will be there, right?
Yes, sir.
Are you getting my point?
Yes, sir. Yes.
So then all the units can be cancelled out, na? That's what I'm telling you. Similar unit will be there, na? Are you
Yes,
getting?
sir. Yes.
That is what I'm telling you. So what it is saying, let's say that if I will give you, this is a very interesting example. If you will do it, then you will able to know correlation is independent of change of origin and change of score. So let's see. You just try, okay? The other one I already have given you example. So just write it down. This one. Suppose a variable. Bhakti ma'am, please try this.
Sir, Bhakti maybe is not there.
Okay. Suppose a variable y and Sangeeta is not there.
Yes, sir. Sangeeta ma'am is also not there. Yes.
And Chinmay madam.
Chinmay madam is there.
Okay. Suppose a variable y is an exact linear function of x, means y is equal to lambda. This is lambda, okay, not chi square. Huh? This is like this, lambda plus, or I will write lambda plus mu x. Lambda and mu are constant. Wait. And z is a third variable over here because y is given over here, right? And z is a third variable. So you have to prove that sigma xz is equal to, means sigma rho xz will be equal to rho yz. Clear? Madhusudha?
Yes, sir.
So tomorrow you show me, okay?
Yes, sir. Yes.
So what we have learned, okay. Another one, who can tell me? Sigma square x bar, just what will be the formula? Sigma square x bar means variance of x bar. It will be equal to sigma square x upon n, right? So there are various you can say interesting examples are there. We will do it later on. But I think with this we will stop, okay? And tomorrow we will take the other topics. Right, Madhusmita?
Sir, I have a small doubt. Sir, in the you already mentioned x and y is a linear, but z is the third variable. It is linear or what?
Linear. Yes.
Linear. Okay, sir.
Okay. That is the third variable. Z is the third variable. Okay. So